Read for us the definition of primary pollutant, please, Tommy.
What?
Read the definition of primary pollutant, please.
Pollutant that is put directly into the air by human activity.
And we say air, but it could be into the soil, into the water as well. So primary pollutant is usually kind of a basic kind of thing. And so a lot of times primary pollutant are going to be things like carbon monoxide. Capital C, capital O represents carbon monoxide. Particulate matter. So when we burn things, it doesn't burn completely. And so there's some ash and dust that gets into the air. That's particulate matter. So when you see smoke, what you're looking at is the itty bitty little pieces of matter that are being kicked up because hot air rises. It's being kicked up into the atmosphere. So carbon monoxide, capital C, capital O, is the chemical formula for carbon monoxide. Particulate matter, so an example of particulate matter is smoke. And then volatile organic compounds. So an example of volatile organic compounds is gasoline. You have gasoline sitting out, it's going to evaporate. That evaporates, it goes into the atmosphere. Carbon monoxide, particulate matter like smoke, volatile organic compounds like gasoline.
I've tried this before.
Okay.
What?
It's like a big fruit.
What?
All right, so highlight the term primary pollutants, box in your examples. Moving on. Secondary pollutant. Read for us the definition of secondary pollutant, please. Hang on, I have somebody who's here. Jade. All right, so now we put the primary pollutant into the atmosphere, and now it's going to react with either other pollutants, or react with water vapor, or react with something in the soil, or react with something in the water. So, some examples of secondary, or an example. No, I have two examples. So I'm on the right-hand side at the top of the page. I'm all the way at the top of the page.
Ground level ozone.
Ground level ozone.
Does that mean the like pollutants interact with the ozone layer with these secondary?
No. Ground level ozone is a pollutant. So ozone in the stratosphere is good ozone. But when it's down here by the ground, it's a pollutant. And so a primary pollutant that we put into the atmosphere is reacting with stuff in the atmosphere to create ground level ozone. So hydrocarbons and nitrogen oxides are put into the atmosphere, and whenever we have sunlight that provides the energy, it's going to create our ground level ozone. So hydrocarbons plus nitrogen oxides plus sunlight give us our ground level ozone, which is a secondary pollutant. So ozone is O3. We can inhale ozone, but our bodies cannot process it. It can't break it apart to get the oxygen. However, ozone can stick to our red blood cells. It sticks to red blood cells just like O2 does. So if it's taking the place of O2, then O2 has nowhere to bond. And so essentially your cells don't get the oxygen it needs, even though it has oxygen on it. It's not a form of oxygen they can use. Essentially. Carbon dioxide does the same thing, but we exhale and we get that out. But if you're in an environment with too much carbon dioxide, it's going to stick to your red blood cells. Carbon monoxide does the same thing. It takes the place on your red blood cells that oxygen needs to take. So all of those basically suffocate. So the hydrocarbons, we can get hydrocarbons from burning wood, from evaporation of the gasoline, of our liquid fuels. We get the nitrogen oxides from processing, burning fossil fuels. And we get the sunlight from the sunlight. So hydrocarbons, we release hydrocarbons into the atmosphere when we burn wood, when we have those volatile organic compounds evaporate into the atmosphere. The nitrogen oxides come from using fossil fuels. And then the energy from the sunlight creates the ground level ozone. All right, another example of a secondary pollutant is acid rain. Let's see. Put the phone away. All right, so in this situation, we have nitrogen oxides, we have oxygen, we have water, the nitrogen oxides come from volcanoes, come from burning fossil fuels. When they combine with the water vapor and oxygen in the air, they make that water vapor, they make a condensate that is acidic. So it's going to fall as an acid or something that is acidic. The closer that a person lives or a building is to an industrial zone that has more of these pollutants, the more acidic the rain is and the more damage is observed.
That's one in some states there's been recordings of like coal plants and it was like stone
Yep. And that's probably where our little George Washington statue came from. We're going to industrialize it downtown city. All right, second color highlighter. Highlight secondary pollutants. Highlight ground level ozone, acid rain. Box all of that information in. All right, next we have smog. April, would you read for us the definition of smog, please? Exhaust. Urban. All right. So now we've got some of the primary pollutants that we're adding. We've got it interacting with this air and the sunlight that's already there. Smog is kind of like fog, except smog has those pollutants in it. Fog is only going to be occurring whenever you have different temperatures clashing. So a lot of times we see fog in the fall when ponds are still, the water in the ponds are still warm, but at night it gets really cold. And so you have warm water turns into water vapor and you have cold air above it, and so you see that fog there. Smog doesn't have anything to do necessarily with temperature because it's just whenever we're putting those pollutants out into the atmosphere. All right, everybody's back in. Temperature inversion. Temperature inversion, please. Somebody's here. Aiden.
One is about cooler, about any pollutants
before we actually get into our little diagram of temperature inversion, we have to take a step back and look to see how air is actually flowing. Do we recognize this little up the arrow, down the arrow? Do you remember what it's called?
Circulation.
Yep, convection currents, convection current. So warm air rises, cool air sinks. So when warm air is allowed to rise in the atmosphere, it creates a vacuum, if you will. We can't have nothing there. So wherever the cool air is sinking at, that cool air is going to replace the warm air that rises in the atmosphere. And that's what we feel as wind. So the next time you're out and it's windy and you're standing in the wind and you feel the wind hitting your face, then you know that it has to be a low, high pressure area in front of you, low pressure area in back of you, cool air in front, warm air in the back, in order to get that wind to be created. So on good days, warm air is going to rise naturally in the atmosphere. On days where we have like a dome or a cap or an inversion of temperatures in the upper atmosphere, it doesn't allow that warm air to continually rise. Warm air is going to rise until it gets cooled off itself or it's into a place where it's not less dense than the air around it. So if it starts off in cooler air and then it hits a pocket of warmer air, well, all of a sudden it's not less dense than the warmer air because it is warm air, so the density is the same, so it's not going to rise anymore. It's not going to float anymore. And so that layer of warm air essentially acts like a cap to hold it down so it can't keep moving up in the atmosphere. If it can't keep moving up in the atmosphere, then there is no vacuum that's created and it's not going to pull the air in from the high pressure area. So that means everything is going to be stale and stagnant and the pollution is going to sit where it's at. Good days, we want air movement because it moves the pollutants around. On bad days, when we have temperature inversion and it holds the pollutants in one place, that's when you have the ozone alert days and they tell you don't gas up or anything like that because the air isn't moving to move the pollutants out. So that's the little picture that you have. Normal conditions, it's showing how that warm air continues to rise in the atmosphere. But when we have that temperature inversion, we have a layer of warmer air that's in between, and so the warm air can rise until it hits that warmer area, and now all of a sudden it's not as dense, or it doesn't have a different density. It's not less dense than that, so it can't keep rising up in the atmosphere. Yep, this gets taped in, put it underneath wind, so that helps you.
They don't have to be able to get it.
No, we don't need to get underneath it. Get you a third different color highlighter, highlight temperature inversion, and then box in your picture that represents temperature inversion. Forgot to snag acid precipitation when we were talking about it, so we'll do it now. Read for us the definition of acid rain, acid precipitation. Somebody's here. Elaine. All right. And so we kind of looked at the pH scale yesterday on the little Kahoot from 0 to 14. Things that are from 7 to 14, they get more and more basic. Things that are from 0 to 2 get more and more acidic. Now we know things that are very acidic are bad. Acids can react with skin, can react with stuff and form a chemical reaction that destroys them. The thing is that the more basic a substance is, that's bad too. So drain cleaner is a very basic substance. It's like a 13, 12, 13, something on the scale. And if you get that on your skin, that's bad. It's going to react with your skin. It's going to be a chemical reaction. I mean, that's what drain cleaner does. Is when you pour it down the drain, it's tearing up the stuff that's in there to clear out the drain. So things that are very basic are bad. Things that are very acidic are bad. But acid rain means that the pH is a low number. It's very acidic. All right, there's one thing that we need to add to this that wasn't on the vocab term. That is ocean acidification. Okay, let's do this first. Ocean acidification. Try to do that. Ocean acidification. 2 CO2 plus 2 H2O yields 2 H2CO3. Do we know what CO2 is? Carbon dioxide. H2O?
Water.
All right. So, oceans, water, big bodies of water, they can absorb a lot of carbon dioxide, and that's what they do to kind of buffer the amount of carbon dioxide on the earth, and that's great to a point. Once they start pulling in and absorbing too much carbon dioxide, it reacts with the water and it forms carbonic acid. So once again, way back right before fall break, the little activity that you did, it talked about ocean acidification and how coral reefs not only are bleaching, but they're being worn away. Shells of sea critters are being worn away because they're basically just kind of living in an acidic environment. And so that's why, is because the CO2 is reacting with H2O, creating carbonic acid. Same thing with the bottle of pop. That's why dentists don't like you to drink pop, because you pump the carbon dioxide into water and it's creating carbonic acid that you're basically bathing your teeth in every time you take a sip of it. There you go. Well, is that one carbonated?
Monster, yeah.
Is it carbonated? Okay. All right. So it's basically wearing away the enamel of your teeth, and so you can't, once you lose your enamel, you can't get it back. So they don't like it. All right. Water is able to absorb carbon dioxide, but this creates carbonic acid, which has a pH of 4, leading to ongoing decrease in the pH of the Earth's oceans. Water is able to absorb carbon dioxide, but this creates carbonic acid, which has a pH of 4, leading to the ongoing decrease in pH of Earth's oceans. Water is able to absorb carbon dioxide, but this creates carbonic acid, which has a pH of 4, leading to the ongoing decrease in pH of Earth's oceans. Water is able to absorb carbon dioxide, but this creates carbonic acid, pH 4, leading to the ongoing decrease in pH of Earth's oceans. Thanks for the one.
You are.
Canadian kids have those.
Okay.
That helps you out.
Water is able to absorb carbon dioxide, but this creates carbonic acid, pH of 4, leading to the ongoing decrease in pH of Earth's oceans.
Maybe we're lucky
Oh, they're monster cards.
The ongoing
Oh, ongoing decrease in pH of Earth's oceans. Sorry, I was distracted by the acid resistant monster.
Oh, because the earth, the ocean is slowly becoming acidic. So it's
I do have a question. We tend to find a lot of fossil fuels in desert areas. Oh, is there a mineral correlation to that?
Well, but that's not entirely accurate because Pittsburgh County was a lot of coal mining not too long ago. The environment that we're in now is different than when it was formed, so depending on what climate influences it had, it changed it. So, all right, hang on. Whoa, Nellie, we've got 2 labs we got to fit in. We've got a little bit more that we have to add today. All right, flip to the next page. When we talk about illnesses resulting from pollutants, they can, a lot of times we'll say acute, chronic, congenital. We talk about illnesses in terms of acute, chronic, and congenital. If it's acute, that means short-term, sudden. Generally speaking, get away from the pollutant and it'll be all right. Acute, short-term, sudden. A little angle. Oh, you have to home. Okay. Chronic. You guys are so fun. Chronic, long-term illness or illness with no cure. So sometimes if you have exposure to pollutants repeatedly over a long period of time, your illness might be chronic. Up in St. Louis County where I used to live, thank goodness I don't live there anymore, but they have a place where they used to dump all of the radioactive material from when Mallincroft, whatever the company was developing the atomic bombs. So, I mean, it's radioactive waste. They don't know what to do with it. Put it in a drum, seal it real good, put it underneath in a landfill. Hey, we'll be good. Well, then all of a sudden that broke the seal on it. It was leaking out into Coldwater Creek, and now there's tons of cancer clusters up in the area. And that's chronic, long-term, and sometimes a fatal issue that they have to deal with. I mean, what are you going to do with it? It's going to be radioactive. So now the cleanup is that they're scooping it up and they're taking it to another state. Like, which one has the big cave that they're putting it in? Utah? I don't know. Where they're taking all the radioactive waste, and so now that's what they're doing is they have to pull up all the soil because the soil is contaminated, and they're taking it somewhere else. So chronic long-term illness can be a result of repetitive or long-term exposure to pollutants. Congenital is something that's present from birth. It's most often it's inherited, but pollutants can cause congenital birth defects. If mom or grandma was exposed to pollutants, then they can be giving it to their offspring and not even realize it.
Well, no. It means like, it doesn't mean like you're a baby and then it means like
You're born with it. You're born with it. So if it's genetic, if it's something that's genetic, it's while you're being formed. If it's within your genes, then you pass it on to your offspring. But if grandma was exposed to pollutants, then she can pass it on to her daughter, who can pass it on to her child, and they wouldn't know anything about it. Well, yeah, that's congenital. If you're born with an issue, then yeah.
I was thinking about the baby being born healthy, but
No.
the breast milk being like.
That's probably chronic. So yeah, baby's born healthy and then goes out and plays in Coldwater Creek where there's all these radioactive then they have chronic illness. All right. Some examples. Oh, let's just do these. So I've got a data table here. I know you won't listen to my melodious voice if I show it all to you at the same time. So some examples of comparisons of acute, chronic, and congenital illnesses. acute, short term, not necessarily lasting. So if you get a headache, that would probably be considered an acute issue. It's not going to take very long to take some aspirin, or maybe you just need to hydrate and you're good to go. Allergic reaction. Generally speaking, allergic reactions, if you take some allergy medicine or just stop rubbing yourself with poison ivy, then you're probably going to be okay.
Yeah, my brother got home yesterday, and I was like, "What'd you do? Get knocked out?" He's like, "No, it's poison ivy." It looked like his face was like swollen.
Yeah.
I'm the only person in my family that
Really?
I cannot get poison ivy.
I used to be able to pull it up, and now I can't touch it without getting it. Getting old scratch.
You should flex on, start growing plants in your house.
That would keep your brother away. Infections, generally speaking, are going to be acute because you're going to take some medication to clear them up. And then irritation from pollutants. So you get something on your skin, it might cause a rash, but you wash it off and in a few days it's gone. You breathe in smoke, it might cause you to cough, it might cause irritation, but in a little while it's gone because your body's taking care of it. But these are short-term kind of things. They're not going to be lasting. Examples of chronic illnesses. So migraines, that's not a headache that you get. If you have migraines, then you know that you get them periodically, probably throughout long periods of time, if not through your lifetime. Asthma is a condition that we can treat and you can manage, but generally speaking, asthma is something that you have to deal with your entire life. And of course, cancer is a chronic illness. Migraines, asthma, cancer. Well, they're all pretty rough. If you've had migraines, then you know. If you had asthma, then breathing is kind of, central to existence. And if you can't. But cancers do have treatments too. I mean, there's some people that get cancer and then they're in remission. And there's, not all of them are fatal, but some of them are. Congenital heart disease, that means you're born with issues of the heart. Chromosomal abnormalities, they could lead to cancer. Some chromosomal abnormalities are so bad that the baby is born but doesn't survive very long. One of the genetic abnormalities we look at in biomed is Tay-Sachs disease, and so the baby usually gets to be like 2 or 3 years old, and then all of a sudden they can't process the fat that builds up in their brain. They can't break it down, and so it basically strangles their brain cells. Congenital heart diseases, chromosomal abnormalities. Pardon? That's a chromosomal abnormality. Trisomy 21. But there's trisomy 18, there's trisomy 15. I want to say trisomy 18 is like pretty much fatal. It's either 18 or 15 that are really bad. Oh, yeah. So, pollutants outside, right? Go inside, right? Because you'll be safe inside, yeah? Not necessarily.
messed up on the inside.
Oh, well, no, I'm talking about pollutants. I'm not talking about air indoors may be more polluted than air outside. Air indoors might be more polluted than air outside. Air indoors may be more polluted than air outside. Or if you're trying to do good and you seal everything really well to keep the air conditioning in or to keep the heat in or something like that, but you seal everything in there and you also seal in things like cleaning solutions that give off fumes. Sure, that's probably well, and not lit, like just leave the gas running.
That can blow up a house, man.
Building materials. Asbestos used to be touted as one of the great building materials insulators that there was. We didn't know any better. Then all of a sudden you find out that that's not exactly the best thing to have lining your attic. Paint used to include lead. Didn't know that that was bad until we found that out. Poor ventilation, we mentioned that.
Can you discuss this? It's like tiny little shards.
It's like basically little pieces of glass.
And they were
It's like Wolverine in your lungs. It's not very good. Poor or dirty conditions. And so when they say poor, I mean, that doesn't mean like no money poor, because there's plenty of poor people that have cleaner house than I have right now. What that means is like, you have bad living conditions because you have a leak in your roof. We had a leak in our roof. Didn't know there was a leak in the roof, dripped down there, and all of a sudden you see this mold all over the ceiling. Well, that's great. That's a poor living condition. You've got issues with your house. And the tightly sealed building, I just mentioned that. So we're trying to be efficient by sealing everything really good and tight, but then we're just trapping all the bad stuff in there with us. Tightly sealed building for efficiency. All right, let's knock this out. We got two more. Noise pollution can have permanent effects from damage, but can be controlled by appropriate devices and insulation. Y'all have earbuds in, and I can hear your music like halfway across the classroom. That is too loud. Put the big speakers in your vehicle, and you can hear you halfway across McAllister. That's too loud. Nerve cells don't regenerate, and so you break down that the little hairs that are in your ears, then you're out of luck. Noise pollution can have permanent effects from damage, but can be controlled by appropriate devices and insulation. And there is a designated, so 85 decibels for a maximum of 8 hours is the recommended. Make sure that you don't go over that, but it's not regulated. Noise pollution isn't regulated. So 85 decibels could be your lawnmower. I know our lawnmower, like the muffler's busted up on it, and so it's super loud. So if you just go out there and mow and think it's no big deal, you might be exposing yourself to hearing damage just from mowing. Weed eaters are loud. Vacuum cleaners are loud.
everything you use is loud.
Not everything.
Everything I do is loud. This can be loud, this can be loud, this can be loud.
Could be, but not too loud.
Be loud.
All right, last one. Light pollution is wasteful, and it can also cause illness. So people can have like the seasonal affective disorder if they don't have daytime, nighttime lighting conditions. I know folks that can't like sleep at night if they've got a light on, and I know folks that can't sleep at night if they don't have a light.
You can see smoke and stars.
But that's not like an illness or anything.
Hey, there's so much you go out there and you don't see any stars.